In our previous tutorial, we talked about data selection in data frame. Now, in this tutorial, what we're going to be doing is we're going to be taking that a bit further by performing some ufunc operations in Pandas data frame. If you recall, in our previous tutorial, we used some Ghanaian cities as examples. So in this tutorial, what I've done is to broaden the scope a bit. So I've prepared a CSV file to that effect. As you can see on our screen, we have this. We have the Jupyter notebook running, and if you look in my terminal, you see I have the Jupyter kernel running. So this is like some kind of a server that is serving these. No, I mean Safari that is serving this localhost environment. Now, what I'm going to do is I'm going to create a new IPython notebook in my workspace. So I want my working environment to be in the same directory as my CSV file. So I think I've stored my CSV file in documents. So I'm going to open document. So here in document, I have it somewhere here. I think it's down here. Okay, so this is it. This is major cities Ghana star.csv. So this is my CSV file. So what I'm going to be doing is I'm going to create a new IPython notebook inside this working environment. So to do that, I'm going to do new. So this is Python 3. Just going to click on that, and now it says untitled. So what I'm going to do is I'm going to rename it. So I've selected it, so I'm going to rename, and then I'm just going to call this is it Ghana cities. Let me just call it cities dot IPython notebook. So we have this. Now I can open it by double clicking this. So now it's gonna open. Okay, so see, I should select. I'm just gonna do this and then select this like this. Okay, so now here we can start writing our code to run to implement some universal functions operations on our CSV file. But then before we get into the whole ufunc operations, I'm going to try to read our CSV file so we can get a glimpse of what we have there. So the first thing I'm going to do is I'm going to import pandas as PD. That's the alias. I'm going to import numpy. We're going to make use of numpy as well as np. Okay, and then I'm going to read my data, so I can do data equals to pd dot read csv, and then since I'm in the same work since my CSV file is in my working environment, so I don't have a problem with that. I can just pass the name of my CSV file here. So I think it's here. What did I call it? I call it. I don't know why it's always like. So I call it major. Oh, I can't copy this. Major cities Ghana stats.csv. Okay, so major cities Ghana stats.csv. So that's what we have there. Okay. So to read our CSV file, we make use of this pandas method, read underscore CSV. So let's see whether we're able to read our CSV. I'm just going to do data.info. So this is going to give us some information about our CSV file. So to run this cell, I'm going to make use of this play button. So it says run this cell. So I'm going to click on this. Okay, so our CSV file is up and running. So here we have some information about our data. So it's data columns, 5 columns. We have 48 rows. So it says 48 entries. The index 0 to 47. Then we have 48 rows in all of our data. Okay. To get the first 5 rows, I can do data.head, and then I'm going to run this cell. Okay, so now we have our data dot we have the first 5 rows in our data. I don't like using the entire screen. I don't know. And okay, we're just gonna roll with it anyway. So this is our first 5 rows. We have 5 columns, 1, 2, 3, 4, 5. So this is essentially a data frame. Remember, we see a data frame has rows, it has labels and then indexes. So this is first 5 rows, index 0 to 4. So we have a city, we have Accra, this population, land area in kilometers squared, density, population per kilometer squared, and then we have the region. Okay, so that's what we have. And just as we did for data.head, we can get the last 5 rows by doing data.tail. And then we can run this, and then we get the last 5 rows in our data. Okay, so that's done. Now let's get into performing ufunc operations on data. Ufunc, if you've been following with our tutorial, is short for universal functions. So they're used to perform fast element-wise operations on data. We discussed ufuncs in NumPy. Now we are discussing ufuncs in Pandas as well. Now, what sort of ufunc operations might we perform on our data? We could do logarithmic transformation. To perform logarithmic transformation, we could do np.log, for instance, if you remember, and we can use that on our population column. So when we do this, we can squash high variance in our data. So if we go up here, so look at the last 5 rows here. You see the population here, Pando is 56,312, is it? And then Wenchi is 56,599. Okay, now if we go up, look at Accra. Accra is 5,592,780. Kumasi is 4,297,984. Now, when we do logarithmic transformation, for instance, we realize Accra, those cities, Accra, Kumasi, those with the largest population. So we can transform in such a way that the distribution becomes easier to visualize or use. For instance, say we were performing machine learning module. So that's why we might want to do logarithmic transformation. Okay, we can also do precision rounding. For instance, you look at our density, see the density column, realize the whole number. Okay, now when we do precision rounding, we can recalculate our density. So say our density is population over land area. So when we recalculate our density, we can do np dot round, that is numpy dot the round method. That's the ufunc we can use to accomplish our precision rounding. So what this does is it ensures that our density rounded remains clean. So we can recalculate our density, say, to 2 decimal places. So that is going to remain consistent in our column. So we can even create a new column to that effect. So that's another thing we might do. We could also do vectorized categorization. So for instance, we can flag cities that have maybe population over 1 million as metropolis, and then those that don't have up to 1 million population, maybe we give them another label, so to speak. Okay, we can also do something like z-score. For our z-score, if you've been following along, z-score, it's a measure of how many standard deviations a data point is from the mean. So when we do z-score, it allows for standardization of our data, so we can compare different data sets and identify outliers. Maybe you need to determine probabilities within a normal distribution. We can do that if we want. So I think I've done too much. I've done enough talking. Let's get into our ufunc operations and let's see what we might achieve. So we talked about logarithmic transformation. So let's accomplish that, and then we can create new columns to inject the result of our logarithmic transformation. So let's look at how we might do that. I'm going to scroll down here, and then here we can do, let's see, I'm going to comment this. I'm going to call this log transformation. Okay, and then here we can do data. So this is going to be our new column label. So I'm going to call this log transformation, and then we're going to do np.log. Remember, we said we're going to use this, and then to do our logarithmic transformation, we're going to make use of the population column. So this is going to be population, like so. Okay, so the result of this is going to be stored in this new column that we have. So if I now do data.info and I'll run this cell, so it says now we have 6 columns. Remember, we had 5, 1, 2, 3, 4, 5 before. Now we have 6 columns because we've added this log transformation to our data. So I can just go down like this, and then one more time we can do data.head just to get a glimpse of what we have now. So now we have log transformation column here. So you realize that the data has been squashed. So this looks a bit preferable in the event that we might want to visualize our data. Okay, so these are not too far from each other in terms of the values. Okay, so that's that for logarithmic transformation. So we made use of numpy.log method, ufunc method to accomplish that. Okay, now what about precision rounding? We can do for precision rounding, say we can recalculate our density such that our recalculated density has two decimal points, or those two decimal places if you like. So we can do data. So this is going to be our new column. So we can call this, what should we call this? We can call this density rounded. And that spelling is wrong. Density rounded. And then we can set this to, okay, now we can make use of ufunc method np.round, like so. So I've explained what is the whole point of precision rounding, so I'm not going to go back again. Okay, so in here we can pass our data column. So that's going to be population, and then we're going to do divided by data, and that's is the land area. Okay, land area in kilometers squared. So I'm going to copy this because this is more involved. Control C, Command C. So okay, so that's that. And then I have to specify the decimal point. So that's we want 2. Okay. So good. So this is a new column now. If I do data.info, we should have added a new column if this code runs successfully. Let me see to see I didn't make any blunder. All right, so let's run this. Okay, now it says total 7 columns. Okay, so we've added a new column. To see what we've done, let's look at data.head. Okay, now density rounding, you see 2 decimal places, like so. Good. All right, so that's for precision rounding. Let's look at vectorized categorization. Vectorized categorization, like I said, say we can decide to categorize a city with, say, population of greater than 1 million. We can categorize as metropolis or whatever. All right, so let's see how we might achieve that. So here we can do vectorized categorization. So here, what should we do? Data category. Do we have it? Okay, so this is going to be our new column, data category. So that's our new column where we're going to store the results of our vectorized categorization. So now we can do np.where. So this is our ufunc function that we're using. So okay, what do we want to pass here? We have our column data, data with population, okay, and then we can say we want to pass set a condition. So if if our population is greater than 1 million, so that's 6. Okay, so we call that metropolis. Otherwise we just call it major city. So that's one way of looking at it. That's how we look at this. Okay. So this hopefully should give us a new column known as category, and then this code, if it runs, then we should have either metropolis or major city in our category. So I'm just going to do data dot head, and then I'm going to run this. Okay, so now we have a new column category here. This is cool. So for Accra, Accra is categorized as metropolis. Kumasi is metropolis. Secondly, Takoradi and the rest major city, like so. Okay. Let's do for z-score outlier detection. Okay, so let's do for that. I'm just gonna click down here, and I'm gonna do what's it called? Z-score outlier detection. I've explained what this is doing, so I'm not gonna re-explain. All right. So the first thing we're going to do is we're going to identify cities with unusual land areas. So to do that, let's do area mean. And then this is going to be equals to np.mean. So we're going to use this to calculate the mean. So we can do data, and then there's going to be our land area in kilometers squared. Okay, so that's going to calculate the mean for our land area there. All right, so the next thing we're going to do is going to calculate our standard deviation. So that's going to be np.standard deviation. Again, we're going to calculate the standard deviation of our land area in kilometers squared. Okay, and then after that, we're going to do set our new column. So this is going to be what should we call it? Land area z z score. Okay, all right, so then we can do a bit of maths here. We can do data, and then here we can do land area in kilometers squared minus area mean, and then everything divided by area standard deviation. Okay, so if this works, we should have a new column known as land area z-score. Okay, before we go into outliers, let's look whether we have this already, because if this didn't work, then we cannot calculate outliers. So let's see. If I do data dot head, so let's see, let's run this and let's see. Okay, so this works. So we have land area z-score. So here, this is our new column here. So this works. Okay, so let's move on, and then let's see how we might calculate for outliers. So for outliers, set this to data, and then in here we can do np.absolute, and then in here we can pass our data and then the column, which is going to be land area z-score. Okay, so for instance, we can filter for outliers greater than 2 or less than 2. So in this case, let's look for greater than 2. Okay, so pay attention to what we have here. So we want to fit off outliers greater than 2. So to do that, let's see. Just print outliers, print outliers, print outliers. Okay, let me just run this and let's see. Okay, so we have what did I do? Land area is its score, NB. Okay, I think I was right with what I did. Okay, so for our outliers, okay, I get. So for we have two cities, Accra and Kumasi. Remember, we look for outliers greater than 2, so obviously this Accra and Kumasi are both greater than 2, so that's what we have here. So for our land area in kilometers, we have these values. For density, we have this, and then for the rest, we have that. So that's how we might create. We might get for our land for outliers. Now, if you look at this, you realize it's printing all the columns. So we can decide to print some selected columns for outliers. So we can do outliers, for instance, and then here we can do. So we want for city. Okay, so let's get for city. Okay, let's get for city. City. We can also get from okay land area in kilometers squared. Let's get for land area in kilometers squared. Okay, and then what else should we get? Let's get for land area z-score. So here we can do land area. No, land area z-score, like so. Okay, so let's see if this runs. Okay, so I think we get. So now we don't have everything. We just have these selected columns: city, land area in kilometers square, land area z-score. So interesting. So these are some of the ufunc operations we can perform on our major Ghanaian cities data. I don't know. Maybe we should do some data visualization so that we can visualize and better understand some of the behaviors or the attributes of our data. Or maybe I'll pause it and then maybe the next video we're going to do that. Okay, so I'm just going to pause here for now so that this video doesn't get too long. Alright guys, I'll see you guys.